So I'm going to start with our first speaker. Don Luman received his PhD in geography from the University of Illinois at Urbana-Champaign. And he was there with our very own Darrell Watson, so they go back together. Following a university teaching career of over 20 years at Illinois State University and Northern Illinois University, Don joined the Illinois Natural History Survey and later the Illinois State Geological Survey. While his teaching and research have focused on the applications of remote sensing technologies to natural resource applications, Don also gets involved in many other activities. I know that many of you attended the Galena premiere of the film that Don created, Erosion of the Land and Erosion of the People, Illinois in the Great Depression. Did a lot of you go to that? Yeah, it was a great event for us. Don is also an avid cyclist, and we're talking a little bit about the idea of a geobike tour, so stay tuned for that. That's going to be something cool coming up. And now let's just get to our program, and our first speaker is going to be Don Luman. Don?
Well, thank you very much for that great introduction. And this is a very special, I think, opportunity for Sam and I to speak on a topic that has taken us 3 years of research to complete. And why don't we go ahead to our first slide there, Sam. And what do you got? There, okay. Out in the front table, there's a few dozen copies of the front page of a scientific circular that Sam and I just co-authored and was published in July of this year. So everything you're going to pretty much see tonight and hear tonight is contained in that circular. And since you people paid for it, the circular, the handout out in the front, has information where you can actually go directly to and download it free of charge, since you citizens of the state have paid for the research for Sam and I for over 3 years. And what you'll get for that is the actual copy of the circular and all the research, and also a large map, all again online, and you can print those for yourself. Let's go to the next slide. Okay, so my part in this presentation is I'm going to present the remote sensing, the imagery and mapping background as to how we found out some of the things that we actually did the research on. And I would say in the 45 years of my career, as a remote sensing scientist, studying imagery and maps and all kinds of interesting phenomena, this phenomena that occurred in the summer of 2012 was probably one of the most interesting events, in that it was very short-lived, comparatively, only a few months in time, but it also, all of the factors that normally frustrate remote sensing researchers, Murphy's Law was not in effect. We in fact had all the factors came together to make an unusually rich research project, and that's what I'm going to try to set up for before Sam talks about the geology. You may have already been reading, this drought was recorded by NOAA's National Climatic Center, rated as the 6th worst drought on record, not only here in Illinois, but in the Midwest. They actually compare it to the droughts that occurred during the Dust Bowl in the 1930s, where in that case, almost 80% of the United States was in drought. In our case, just about 60% of the United States was in drought conditions. And if you look at this right here, this is one of the U.S. Drought Monitor's maps for August, right, almost during the peak of the drought in 2012. About 81, almost 82% of the state of Illinois was either in that severe drought or extreme drought during the summer. So it was a very severe drought, and this is one of the factors that brought us to this research. Go ahead and push the next slide. And if you look up here in Joe Daviess County, of course there's other parts of the state. But in Joe Daviess County, during that year, the Illinois Water Survey has registered that somewhere between 12 and 16, over 20 inches, Joe Daviess was behind in rainfall. Again, another factor that you'll see what brings the research to focus. Okay, next slide. And there you go. So we're just going to let this run. I think it'll run on its own. Give it one more little shove there. Whoop. Let's back. Can you back up? Yeah. Went the wrong way. Everybody should. We're going to get this one done really quick. And further back. Back. One more. Or we can. Okay. And it's an animation, so if you just, I think, just set it to going. If you just give it. Maybe we'll just bypass that one. How about that? What this one is showing is, can you back this one up just one? Okay, that's good right there. The hurricane season for 2012, here was another factor that contributed to all the environmental factors, including the drought. The hurricane season of 2012 was the third largest on record, with 19 storms, 19 hurricanes, and these are all the different paths for the 19 storms. Interestingly, here's this one that started out in the mid-Atlantic, came all the way through the Caribbean, up in the Gulf of Mexico, and actually reached Missouri. What that did is that you would think, well, how did that help or increase or exacerbate the drought? It kind of did the reverse for up here in Joe Daviess County. If we go to the next slide. What it did was, here's the actual hurricane, the end of the hurricane, and it's centered down here in Missouri. So what it did is alleviated the drought in every part of the state except right up here. If that hurricane would have moved just a little further north, we might not have had some of the features that, or the features would not have been as extreme as what we found out that occurred during the months of August and September. Okay, next. Okay, so by the time late June and July came, we'll have to give credit to a person here in the audience, Matthew Alschuler, if you put your hand up. I guess the story was, I hear various versions of it, but he was out running or walking or whatever, getting ready for some kind of marathon thing or something, I don't know. And he looked out in the fields and he saw these funny stripes out in the fields. And he called, not his friend Don, but he called Sam. He said, you know, there's some odd things going on up here in these fields. And what occurred is on the ground, this is the way it looked. Okay? And it does look a little strange. But then, if you go to the next slide, there is that same slide. This is what this looks like from the ground. This is where it's taken. And now if you see an aerial photo, you're going, oh my gosh, what is going on in that field? And it's not just any field, it's an alfalfa field. It's not a corn field, it's not a soybean field, it's an alfalfa field. And this crazy network of lines going all through the fields was first like, well, what have we captured here? And over here is a cornfield, and you can see it's gone. It's not present. Okay, let's go on to the next slide. And here's another aerial photo that Sam took, actually, on July 19th. Again, showing these very unusual networks going through, again, alfalfa fields. Pretty much concentrated on alfalfa fields. All right, go ahead. And the reason for this is we started doing some research. I grew up on a farm. I think some of you grew up on farms, or many of you. And you remember all summer during your high school years and middle school years putting up endless years of putting up hay bales of alfalfa or clover, and I really got to kind of hate this crop. I hate that every summer. You know. So, and here it comes back again. Well, alfalfa as a plant is a very interesting plant in that after just 2 months of germination, it's already the root, taproot's gone down to about a foot, 4.5 months, 5 foot, couple of years, and alfalfa is a perennial, so it's very persistent. Not only will go down to 10 feet, but in optimum conditions, the taproot will go down to about 20 feet in depth. That's not true of corn, that's not true of soybeans. It's a unique indicator crop. Okay, let's go to the next. Now, I've done quite a bit of work on land cover in Illinois, and I've always noticed over the last 20 years, Joe Daviess County, Joe Daviess, that's a local, right? Joe Daviess County is unique almost in the state of Illinois, at least up in northern Illinois. So most of Illinois, if you look at it in terms of what kind of cover types or crop types, is corn and beans. In fact, 3/4 of the land area, like in Champaign County, is corn and beans. That's our landscape, our monotypic landscape. Up here in Joe Daviess, those two crops only account for about 30%. A large percentage of the county, 40%, is in hay crops like alfalfa, clover, and pasture lands. Now, you just got to kind of remember that statistic. Okay, go to the next slide. And we'll come back to that in a second. So during the summer, Sam and I collected 4 different dates of imagery. This was quite rare, actually, to have the types of imagery and the willingness on the part of different agencies, federal, state, and local, to acquire this imagery. So the U.S. Department of Agriculture flies your county every June through August, called the National National Agriculture Imagery Program. Sam actually did a special flight in July 19th from the air. Got a lot of interesting aerials. Then we had the Illinois Department of Transportation fly a reconnaissance flight up here for us and took photos of various fields that we had spec'd out. And finally, this sort of interesting photography that showed up on Google around the late part of September showed kind of its ending of this period of these, what we're calling vegetated crop lines. Okay, next. So here is Joe Daviess County by itself, just showing land cover in that year. This yellowish, sort of brownish over here is corn and soybeans. And if you look at these green areas, this is all alfalfa or clover. You can't separate the two. And go to the next slide. And what are all these red dots? And Sam and I looked over all this aerial photography we had. We had a lot of aerial photography. And because farmers don't all cut alfalfa on the same date, and they cut it multiple times during the summer, we had to follow this harvesting period during the whole summer. And we ended up with these as our type locations for this phenomenon that we've been trying to look at, what we call these vegetated crop lines. Okay, next. And what you're going to see, since we don't have time to show the whole thing, but they're all included in the circular, we're going to see an area up here along Highway 78, down here by this area, Warren or Nora, and here, okay, and then next slide, we're going to look at these just few areas right here, just to kind of give you a flavor for what, and this is all the different aerial photos that we processed at the Illinois State Geological Survey. Okay, next. One of the things that you have to do as a geologist, scientist, is, well, maybe these vegetated crop lines came from outer space. I don't know. Maybe they were done by these farmers. I don't, because you will get that question, like, how do you know these are really what they are to be? Well, we found in one of the aerial photos this cornfield right up here's the Wisconsin state line. There's I-78, Illinois 78, and there's this field right here in the corner. It's a soybean field, which is very unusual. And if we now go ahead and hit the thing, if we enlarge that photograph, there's this strange line going down through the cornfield, and it terminates in this crevice. Well, right on the road cut. And many of you have probably been through that road cut right by the state line. Well, this might be what we call the smoking gun. There's Sam standing in the crevice, and that crop line goes right up through the field. I mean, that's pretty darn good evidence that they're related. And this is karst topography right here in this limestone. Okay, next. And again, one of our fellow geologists said, you know, you really need to find a quarry with fractures and crevices in the quarry, on the quarry floor, and relate those to the crop lines. I said, you gotta be kidding, we can't find something like that. So we looked at all the photographs, and lo and behold, this is on North Beta Grain Road. Some of you know where that is. It's kind of in the center part of the county. So here's this little abandoned quarry. See these crevices going through here? Well, over here in the waterway, look. And these are alfalfa that is rooted down in the crevices. And the alfalfa is very persistent, but it's very competitive. The plants are very competitive. So the plant roots that get down, that taproot that gets down in the crevice is the ones that survive. The ones next to it during that summer basically died off. So it formed these patterns. And you can see them all through here. So that's again another evidence that actually what we're seeing is something that's somewhere between 2 and 5 feet below the ground surface. Okay, next. And then there were just some crazy areas in the county. This field, which is over on East Union Road, about central part of the county, if you look at this one field, and you can get kind of a scale over here, look at that one field and look at all these crop lines, and they're complicated, and they're curvy, and they're not all going the same direction. And we found out that they're about 4 to 6 feet in width, these that we're looking at. This one is very striking, look at that. Down in this alfalfa field. And this is an alfalfa field that had been harvested, so don't have any patterns. And next. And then you get, I mean, every time you look at something, it's like, holy gosh, where did this come from? And you get this almost what's called a trellis pattern with crevices going off on the sides. I mean, what is going on here? You know, again, another alfalfa field on the east side of the county, and I think we got one more. And very unusual, the drought was so extreme, and remember, corn was not really a very good indicator because it's so shallow rooted, but the drought had become so intense, it was showing up in a cornfield. And you see this pattern? I mean, I feel sorry for the farmer because this is actually the good part of the crop. This is where the corn plants are sitting over crevice. This is all areas that are harmed, so the crop was not producing there. 1 month later, we go to the next photo. Here's the one we got from Google Earth, and the field had been harvested. And if you didn't have the left photo, you wouldn't know that these crop lines are in there, but you can just see vestiges of them. And they're showing up in the residue of the corn after the harvesting has been done. That's how persistent this pattern was. So this is very unusual to see it in corn. And I think we got one more. This one is Sam's favorite. It's just crazy as can be. It's sitting right over there. This is just north of the state line. And you can see the scale of these features by looking at this over here. And then what we did, this was the part that was, the photos were the fun part, kind of. But then, if we go to the next slide, or go to, all of those black lines that showed up, we digitized every vegetated crevice crop line of these about 150 photos. That was pretty tedious, but we had to do it in order to get to the final result, which is, go ahead to the next one. So here's an alfalfa field. They look kind of faint. Here they are digitized. And then typically with a geologic study like this, where you're looking at crevices and fractures on the bedrock surface, you might have a few hundred observations. The drought, along with this alfalfa giving us the indicator crop for the buried fractures, we had a total of 17,855 crop lines, with all of which are crevices on the basement floor. As a result, when you plot them all, we found out there are two directions, kind of a north-northwest, south-southeast, and then a smaller number going in a north-south area. That is very clear evidence that these are not just a random set of lines that you think are setting in the field. There's actually a very much an underlying geology. And with that, I'm going to have Sam come up and talk about the geology.